Imagine waking up tomorrow and finding out that flights are being canceled worldwide, not because of war or a pandemic, but because of a volcano, and worse. Along with that, food gets more expensive, the weather turns strange, harvests fail, and supply chains start to choke. The scariest part, this isn't fiction. It has happened on a smaller scale, and experts fear a scenario on a much bigger one. Before I explain how this works, do you think the world is prepared? Comment right now, prepared or delusional. And at the end, I'll tell you what warning signs are being monitored today. When we think volcano, we picture lava and local destruction. But the global danger often comes from something else. What gets injected into the atmosphere? A major eruption can blast ash and gases, especially sulfur dioxide, so high that it reaches the stratosphere and forms sulfate aerosols, particles that scatter sunlight and can cool the planet for a while. That affects climate, temperature, and rainfall, agriculture, harvests, aviation engines, and visibility, the economy, prices, logistics, insurance, energy. Let's go to a real case that shows the mechanism in action. In 1815, Mount Tambora in Indonesia erupted. What followed went down in history. 1816 became known as the year without a summer in parts of the northern hemisphere. The point isn't it got cold one day. It's the chain reaction: unusual weather, harvest failures, food prices, rising hunger, and instability in multiple regions. And think about it, that was the 19th century, with a global economy far less connected than today. If a historical eruption already disrupted the world back then, here's the uncomfortable question: what happens if it happens again in today's hyper-connected world? Let's translate this into real life today, in 4 waves. Wave 1, sky and flights. Volcanic ash isn't just dust. It can damage jet engines and reduce visibility. Result, flights get canceled, routes change, air cargo stalls. Wave 2, climate and rainfall. Aerosols can shift patterns of temperature and precipitation. It's not endless winter, it's instability. Some regions drier, others wetter, seasons out of sync. Wave 3, food and prices. Agriculture hates surprises. If you lose planting windows, get off-season frosts, or less sunlight, yields drop. Then comes what everyone feels: higher prices at the grocery store. Wave for economy and logistics. With flights down, ports and routes stressed, insurance costs rising, energy markets swinging, the economy shifts into defense mode, and panic plus rumors make it worse. Which wave do you think would hit your daily life the hardest? Flights, food, or prices overall? Comment the number 1, 2, 3, or 4. Sure, but that was 1815. What about today? In 1991, Mount Pinatubo in the Philippines erupted, and the planet experienced temporary global cooling linked to stratospheric aerosols. It's a modern example of how volcanoes can influence the climate system worldwide. Pinatubo was a reminder: Earth has buttons nature can press without warning. Now comes the part that makes the title of this video make sense. There's a type of volcano that could go beyond this, and a lot of people avoid talking about it seriously. When you hear supervolcano, it sounds like clickbait, but the term exists to describe volcanic systems capable of much larger eruptions than typical ones. Here's the key distinction: probability. It's not something that happens every year. Impact. If it happens, it's too big to ignore. Supereruptions are rare, but the cost of the event can be so extreme that even with low odds, the discussion is serious. So why does nobody talk about this seriously? Because it mixes complex science, geology, climate, risk easy, public anxiety, panic spreads fast, and the massive challenge of predicting when the right question isn't, will it happen tomorrow? The right question is, if it happens, do we have a plan? If you had to guess, do you think the world handles fast crises like a blackout better, or slow crises like food prices rising over months? Comment, fast or slow. Here's the good news: these systems are monitored. For example, in Yellowstone, USA, agencies like the USGS publish regular updates and track typical volcanic indicators, such as seismicity, earthquakes, ground deformation, millimeter-scale uplift, subsidence, measured by GPS and satellites, hydrothermal changes, geysers, hot springs, localized changes. One crucial point: monitoring doesn't mean predicting a date, it means tracking whether activity is at background levels or shifting patterns. Public updates from the USGS generally describe whether the system is at background activity and include details like earthquake counts and subtle deformation signals, meaning you can follow it transparently. If you want, I can leave official links in the description so you can follow real updates instead of rumors. Now let's answer the video's question honestly. Are we prepared? It depends on the scale of the event. For a major eruption but not end of the world, we do have better monitoring than in the past, more advanced climate science, international coordination for aviation and alerts. But we also have vulnerabilities: just-in-time supply chains, heavy reliance on air routes, concentrated agricultural production, fast-moving misinformation. So I'd summarize it like this: science is better, but the global system is more fragile. Back to the opening question: prepared or delusional? I want your reasoning in the comments, even one sentence. If this topic felt heavy, remember, talking about risk isn't about creating panic, it's about understanding how the world really works. If this made you think, hit like and subscribe. Because next I can cover how aviation decides to cancel flights because of volcanic ash. Or what happens to food and prices in the first 30 days after a major eruption. Comment which one you want first, flights or food.